Now let's check out Loulee's strategy. What's happening here? What I want you to see is Loulee is now taking note of the place value and again the expanded form, right? 158 divided by 12, she can see as 100 plus 50 plus 8, and the whole thing is divided by 12. And now where Samuel's strategy was this idea of subtraction, right? This repeated subtraction, the how many groups, this is now saying, look, I have 12 groups, right? Right here, I have 12. I want to make 12 equal groups. So think about it, right? I can literally have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Here are my 12 groups. And now I'm going to fill them with 158 dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And right, do you want to watch me do that until we get to 158? No, it's not very efficient. But if we understand division as how many in each group, right, we can see that here. This is called partitive division, right? We're taking this total, in this case, we're started with number 158, and we're partitioning it. We're making 12 equal groups, and our question is, how many then is in each group? That's partitive division or partitioning. Partitioning means we divide it into equal groups, just another way. So what we can see is, all right, and I guess I'll keep this in blue, but I'm going to bring this down here, right? This 100 plus 50 plus 8 is all divided into 12 equal groups. And that's perfect. But maybe you're like, I don't know how to do that. But guess what you do know? You know that every division can be rewritten as multiplication, 100 plus 50 plus 8. And now look at, this is just the distributive property. And so we get 1/12 of 100, 1/12 of 50, plus 1/12 of 8. Or as Loulee wrote it, right? This is the same as 100 divided by 12 plus 50 divided by 12 plus 8 divided by 12. And this is why understanding the relationship between multiplication and division and understanding the meanings of division is absolutely critical to get into fractions, because every single fraction is just a division problem. And understanding this multiplicative relationship, right, this is all, and so maybe for some of you this looks anxiety, panic inducing, right? I don't like all of these fractions. I don't know what's happening. This makes no sense. And we're going to get into fractions. And what I want you to see is when we start dividing whole numbers, when they don't divide equally, right, we can have this idea of a remainder, or we can create this new number called a fraction. It's called a rational number because it's in the form of a ratio, right? A numerator to a denominator. And so what I want you to see, what's not shown here is, right, all of these, and sometimes called improper fractions, right, when the numerator is greater than the denominator, right, what the Loulee is doing is, right, well, again, how many 12s fit into 100, or how many groups of 12 are there in 100? And so we're just taking it piece by piece, place value by place value. You know, if you do 100 divided by 12, then you get, you can do 8 full groups with 4 left over, right? 8 times 12 is 96, right? So likewise, we know 4 groups of 12 would fit into 50. And so again, this relationship, if you think about like, 12 times what number equals 100? Oh, again, that's not working nicely. Or, right, 12 times what number equals 50, right? What number? And that's a really important way to think about, you know, and this idea of computational estimation, right? I can get close. 12, or I can count by 12s, right? 12, 24, 36, 48. Oh, 48 is close to 50. And that's where I get this 4 groups of, 4 on the outside. And then 2 left over means I have 2 twelfths left over, right? And then likewise 8 twelfths, right? That's what it is. 8 divided by 12 is 8 twelfths, right? Not a whole number. There's not a whole group of 12 inside of that 8. There's only 8 out of 12. And so now we can see 4 plus 2 plus 8 is our 14 twelfths here. And now there is a whole group of 12 in there. So, right, 12 plus 12 over 12 plus 2 over 12, right? 14 twelfths, and then this 12 over 12 is the same as 1. So now I want you to try it with number 4 or number 5, or make up your own numbers. Maybe make up like prettier numbers, or numbers that you know are going to work. Like think about 124 divided by 4. And maybe I should have changed the colors here. Let me erase this so I can change the colors. Right, 124 divided by 4. And maybe, I should redo this. Now we can think of this as 100 plus 20 plus 4, all divided by 4. And now, or you think of divided by 4 is the same as, a quarter, taking a fourth of, right? Now I can see why I would do 100 divided by 4 plus 20 divided by 4 plus 4 divided by 4. And like Loulee's doing that vertically, and I showed it horizontally. And now you can see 100 divided by 4, 25, 20 divided by 4, 5, 4 divided by 4, 1, 25 plus 5 plus 1 is 31. Now, check it out. Does that work? Check it with your calculator, right?